Okay, we're group 17 doing assignment number 2 for statistics about the central limit theorem. So a population consists of a collection of all items or things under consideration, whereas a sample is a portion or a subset of a population randomly selected for analysis. Once you have a random sample, it is not obvious that you can say anything about the population it was drawn from. An unusual phenomenon known as the central limit theorem allows us to infer the population parameters, such as population mean and standard deviation, from a single sample of sufficient size taken from the population, usually at an n greater than 30.
So our statistical problem is as such. If the mean number of years between asbestos exposure and death is found to be 25 years with standard deviation of 7 years in a particular country, what is the probability that mean number of years between asbestos exposure death will be 22 to 29 years in a sample of 50 people taken from the community? So our parameters of statistics are as such. Our mean is 25 years for the population. Our population standard deviation is 7 years. The size of our sample from our population is 50. And our parameters are from 22 to 29 years.
So the solution to our problem is we take the question, we broke it down into one probabilistic question. What is the probability that the mean of one 50-person sample taken from that original population lies somewhere between 22 and 29? So this stated mathematically is just the probability that the X bar is between 22 and 29. To calculate this, we utilize the statistical concepts of confidence interval, standard error of the mean in conjunction with z-values.
So continuing, confidence interval is the interval estimate intended to define the range of reasonable values supposed to contain the population mean mu with a certain degree of confidence. The standard error of the mean is an estimate or measure, and the z-value is obtained when a continuous random variable is transformed from a normal distribution to a standard normal distribution.
All right, now to the main calculation. So as mentioned earlier, our P would be between 22 and 29. So we transformed our values to z-values. So the z-value for 22 is 22 minus the standard mean divided by the standard deviation over the square root of n, which is our sample size. And our value equaled negative 3.03 for 22, and for 29, our value turned out to be 4.04. So to find the probability density for the corresponding z-values, we use the z-table, and our value of minus 0.03 ended up being equal to 0.0012, and our z-value for the value 4.04 ended up being 0.9999. So to calculate the final probability, what we needed to do was subtract the value, the z-value of 4.04 from that of negative 3.03. And our final compilation gave us 0.9987. And in percentage, that is 99.87%. And that is the probability that our value would be somewhere between 22 and 29. Thank you.
So we were over by a